Okay, so I'm going to be talking about and teaching scatter plots and correlation as well as association. So the first problem is the figure below shows a scatter plot of IQ and school GPAs for all 78 grade students. Oh, forget that. Oh yeah, 78 seventh grade students in a rural Midwestern school. And then, just a side note, the GPA is recorded on a 12-point grade scale, but I don't think you need to worry about that. So we have our graph right here, and you can see the IQ scores on the x-axis and the GPAs on the y-axis. So the first question is, does this plot show positive association? The answer to this is yeah. So the answer to this is yes, because associations have to do with the arrangement of the dots and how they line up and how they kind of group together on a graph. So a positive association looks like this. The dots kind of going up like that, and that's positive. And a negative association is where the dots go down on the y-axis, or on the x-axis. So this is so in this graph, as you can see, the dots roughly kind of go up. So there is a positive association in this graph. So what is the form of the relationship? The form is, we talk about kind of linear versus nonlinear, and this is roughly linear because, as I drew earlier, the line would kind of, it has to do with whether or not the line, if you drew a line through the, set of dots, if it would show kind of a good summary of the path of the data and the different, GPA and IQ score, kind of the averages and how they kind of line up along the graph. And it is moderately strong because it's not like the lines are kind of linear perfectly, but the grouping does, the grouping is pretty close in certain areas, especially like this one. So I would say linear and moderately strong. And a weak association, on the other hand, would look something like that, where a line couldn't kind of, define the path of the points. So that would be a weak association. The dots aren't very close to each other. So yeah, so this is a fairly strong association, even though there is some dots kind of on the left side that are kind of out of place. So for this one, get rid of that. The question is, at the bottom of the plot are several points that we may call outliers. One student in particular has a very low GPA despite an average IQ score. What are the approximate IQ and GPA for this student? So the points they're talking about are these points right here. And outliers are defined by points on a graph that don't, they're very far away from the averages, the mean, the average points on the graph. So these would be kind of the average points, and these are the outliers, and these are outliers down here as well. So they're they skew away from the average kind of cluster of the data. And so in this particular one, they're asking about these bottom plots. And as you can see here, the GPA of this student, so they're talking about this guy right here. The GPA of this student is very, 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 very small on the y-axis. So that student would have approximately a GPA of 0.4, as you can just kind of see on that line. And then the IQ score, however, is approximately 103. So the easiest, so that's how we find that, just looking at the graph. So the nice part about scatterplots is that when given questions like this, it tells a lot about the data, and you can find specific points on graphs. So that's a nice thing to have. So that's scatterplots. And then our next. Okay, so now we are moving on to least squared regression lines. So this question, the mean height of American women in their early 20s is 64.5 inches with a standard deviation of 2.5 inches. The mean height of men the same age is 68.5 inches with a standard deviation of 2.7 inches. So just gonna write that out. So I'm gonna call the women mean X and standard deviation X. And then Y. Actually, yeah. This just helps me organize. Okay. And correlation, which is R, between the heights of the husbands and their wives is 0.5. And this is all in inches. Okay, so now we have to find the equation of the least squared regression line for predicting the husband's height from the wife's height. So an equation for a least squared regression line is y hat equals a plus bx. So we have to find a and b individually. So to find b, the equation for b is correlation over standard deviation of y. Correlation times standard deviation of y over standard deviation of x. So to find that, we plug in the correlation times the standard deviation of y over the standard deviation of x. And when you do that, that comes out to 0.45. And then a in this equation is the mean of y minus b times the mean of x. So 68.5, the mean of y, minus the correlation, minus b. So that's how, and then that comes out to 33.66. So then you plug it all in, and your equation is going to be, and these are just taking from what you found. I'm sorry. Do not need this extra 7. So 33.67. I'm losing room here. I'm sorry. This is a mess. Okay. So the equation, I'm going to do it incorrectly, is 33.67 plus 0.54x. So that is your the equation for your least squared regression line. So now we move on to part B, which is use your regression line to predict the height of the husband of a woman who is 67 inches tall. So I'm just going to do this first part. So to find this, that's what your x is for right here, to plug in for 67. So you just take your equation. And so now instead you're going to plug in for 67, which comes out to be 69.2. inches. So this number right here, so the correlation is between the heights of husbands and their wives is 0.5. So when you're doing this, you're pretty much saying that a husband who has a wife that's 67 inches tall, just due to the correlation, is going to have approximately, he's going to be 69.8 inches just based on average, and comparing husbands, the average height of a husband compared to their wife. So then the second part of this question is explain why you could have given this result without using the calculator. So you could have found that result also just by using the standard deviation. And 67 inches is one standard deviation above the mean for women. So the mean for women is 64.5, and 67 is one standard deviation above that. So 64.5 plus 2.5 equals 67. So that's another way you could have found it without using the calculator. So the predicted value for the husband's height would be about 68.5. So that's the average of y, which is the husband's height, plus the correlation times the standard deviation of y would come out to that. Is that, yeah.